Welcome to another day on the Journey Shechem. Please do the 2 warm-up questions to the best of your ability, and I'll see you soon. Number 1 asks for oxidation numbers of the underlined element. The first one is chlorine in the polyatomic ion chlorate. I am going to remove the polyatomic ion from the compound. Therefore, I am not interested in the other parts of the compound. Oxygen has a charge of -2. There are 3 of them. That gives me a -6. The overall charge for this polyatomic ion is -1. Therefore, chlorine must be +5. In B, it is also a polyatomic ion. So I will remove the polyatomic ion from the compound, and it has an overall charge of -3. So I set my equation to -3. Oxygen has a charge of -2. There are 4 of them, giving me a total of -8. Therefore, phosphorus must be +5. In this case, we're talking about a compound, and compounds have to be equal to 0. Oxygen's periodic trend is that it is -2, and we always look at the negative position to determine what the positive position is. And the first element is normally positive. Therefore, copper in this case is +2. In this case, we have a polyatomic ion, and when you know your polyatomic ions, you recognize right away that that is a -2. And compounds must be 0. Therefore, tin must be +2. Again, I have a polyatomic ion. So we're reviewing those polyatomic ions as we do our warm-ups. Nitrite has an overall charge of -1. Oxygen is -2. There are 2 of them, which gives me a -4. The overall charge of this polyatomic ion is -1. Therefore, nitrogen is +3. Now, notice here in E, I had more than one of these polyatomic ions, so I have to set them off in parentheses so that I see that they are units, like automobiles, that are all a unit, and so they have to stay together as individuals. Here, chromate, there's only 1 of them, so I don't need to put the parentheses around it. Chromate has an overall charge of -2, so I set my equation equal to -2. Oxygen is -2. There are 4 of them. That gives me a -8. Therefore, chromium is +6. And that's how we practice oxidation numbers. In number 2, we're doing both things. We're going from formulas to compounds and from compounds to formulas. And that's why we need to have Roman numerals, because cobalt can change its oxidation number, so I need to identify what it is. So this Roman numeral is telling me that cobalt is +2. Nitrate is a polyatomic ion with a -1 charge. The common multiple between 2 and 1 is 2, so I need 2 nitrates. CO parentheses NO3 twice. Again, my Roman numeral is telling me that nitrogen has a +3 charge. Oxygen is -2. The common multiple is 6, so I need 2 nitrogens and 3 oxygens, because +6 and -6 is equal to 0, and compounds must be 0. Now, I could also have called this dinitrogen trioxide, but I prefer Roman numerals, so that's how we do that. Now, sodium, notice it does not have a Roman numeral, because sodium is always, always, always +1. And nitride is telling me that this is a binary compound, and nitrogen is normally -3. So the lowest common multiple between 1 and 3 is 3. So I need 3 sodiums and 1 nitrogen. In this case, sodium is always, always, always +1. And I have 2 of them, so that gives me a +2 on the sodium. Therefore, oxygen together, both oxygens must have an overall charge of -2. So that's telling me that it is a polyatomic ion peroxide. This is sodium peroxide. When you have a peroxide, it will always be with something that you know never changes, or in hydrogen's case where it's normally +1. So you can see, otherwise your oxygens are going to be a -2. In this case, calcium is always +2, so I don't need to worry about a Roman numeral. It's just calcium carbonate. Now iron is not in the first column, the second column, or one of the silly 6, so I must have a Roman numeral. I look at the negative position. Hypochlorite is -1. There are 3 of them. That gives me a -3, and therefore iron must be +3 if the compound is to be 0. And all compounds must always be 0. Therefore, this is iron, Roman numeral 3, hypochlorite. There you have it. Now I must tell you something very, very important. And it is that, of course, there are some exceptions. And the exception here is that we have ammonia and the polyatomic ion that you've already have, ammonium, and they are exceptions to the rule as far as the oxidation numbers, because normally we have the positive first. However, in this case, nitrogen is first and it is -3. Technically, it would be better to write this as H3N. But that's not the way we do it, and that's the way it's always been, so we just have to get used to it. I know you can do that. It's just a little something for you to remember. Nitrogen is -3 in this case, and it's exception to the rule. That's all I really needed to tell you today. I'll get a little bit every day, and it all adds up, and eventually you'll just know so much chemistry, you'll be surprised with yourself. So I'm so happy that you were here today, and I can't wait to see you tomorrow. Bye.